So hello guys, am I audible? Hello, am I audible? So, hello guys, am I audible?
Yes, sir, you are audible.
Okay, fine. I'll start, huh, madam? It's 1:50 sharp. I'll start. Let others come and join later. No issue. We have a very limited time.
Okay, sir.
Okay, so let's start with that. Where we left in the last, this was the last slide where we left in the last class. Okay, so my PPT is visible, right, madam?
Yes, sir, it is visible.
Okay. Okay, so deep learning is a form of machine learning that uses a model of computing that's very much inspired by the structure of the brain. So that structure of the brain, the minimum and smallest, biological unit of a brain is a biological neuron. Neuron makes up actually the brain, correct? Now, so each neuron, as you studied in 9th or 10th standard, is having three main parts. One is the dendrite, then is the cell body, another is the action. So dendrite is like, this is the part dendrite, as you can see in this biological neuron. It receives the signal from other neurons, okay? Then this cell body will sum all the inputs which is gets from the other neuron. And then the last part, this axon will transmit the signal to the other cell after processing from here. So the same thing has been used. So as you can see, each neuron will be connected with many of the neurons by these dendrites, and it can provide the data to many other neurons by using the axon, and while in between we have a cell body to process. So the same thing has been used in artificial neuron also. So deep learning is nothing but a collection of statistical machine learning techniques. It is used to learn features hierarchies. The feature hierarchies will be derived in a hierarchical manner. The features from a particular data will be derived based on the concept of artificial neural networks. So the neurons create the biological neural networks, okay? And we are talking about the artificial neural networks. So what is artificial neural networks? It is inspired by the biological neuron. So it is having this structure. See, these are like dendrites, okay? These are like the dendrites which is collecting the information from many other different neurons, and this is like the axon. So axon will give the result back. This is the cell body, yes, which will process, which will sum all of the inputs. Like this is can be also considered as a cell body, and these are the dendrite, and these are the axons, and so on. So yeah, basically the first unit, there will be an input layer. Input layer will be processing each and every different data. Like suppose you are providing a image as an input. So if the image is 28 by 28 and having a n number of pixels, the 28 into 28 into n number of pixel will be inputted. So in the input layer, that many number of the neurons will be there that which will take the input, and then in between there will be many hidden layer which will get the data from the input layer, and one by one will try to retrieve the exact feature of its own, like the features which is matches with this particular value, and then at the end it will respond you back with the output layer, the final output, the final classification. That is how it works. So the example of the image recognition which I had given before, let me check using this particular deep learning network. The first is the high dimensional data will be provided to the input layer. So these are the input layer. So the number of pixel should be equals to the input layer actually in general. The next is that the output received from the input layer will contain the patterns which will be extracted from there. So it will be one by one, the patterns will be extracted through different neurons. And then the output will be fed to the hidden layer. The hidden layer will detect the face, as I told from the in the last lecture. And then the exact face will be determined in the hidden layer 2, and then output will be provided, which will give the classification of different faces. So in this way, the image recognition will be done from a set of from a picture which consists of set of faces. So actually, the neural network, it depends on the concept of artificial neuron. Artificial neuron is also known as the perceptron. Yes, artificial neuron is also known as the perceptron. It's a linear model used for binary classification. So it will classify between different things like A, B, C, D. If you difference between A, B, C, D from a handwritten signature, it will be a classification. If you understand different faces from a set of pictures, that will be classification. If you understand difference between the computer and a keyboard by using the computer program, it will be a classification. If you understand between the Toyota car and a Maruti Suzuki car, between two images of the car, then it will be a classification. It's like that. Discrete output will be there in general in case of the classification problem. So the perceptron models a neuron which has a set of inputs, each of which is given a specific weight. But that weight is very important actually. I'll go through later how this weight is fixed. The neuron will compute some function on this weighted input and gives the output. So as you understand that just simply the data input is not sufficient. Each and every data input is provided with a particular weight. That weight will determine the importance of it. I'll show you how we set the weight very soon. Then when the weight is provided with the input and fed to the body of the, like we have the body now for each and every neuron. So we have a processing element inside, which will sum, like the dendrites will get the data to the cell body of a neuron, and neuron will get the summation of all the signals. Similarly, we'll do the summation of each input multiplied by their weighted value. And we put bias also sometimes. We add some bias also sometimes. That's been not shown over here. Then this processing element will gather all the sum. And then there will be a transfer function. That transfer function will be triggered on a particular threshold. Keep these things in mind. I'll explain later properly. This transfer function or activation function, both are same. Transfer function is also known as the activation function. So it will get to some particular threshold. When that particular threshold will be met, then it will give that particular output. So suppose the value of y, when it is more than 100, output y1, less than 100 but greater than 80, output y2, and less than 80, less than 60, output y3, and less than 60 will be output yn. That's possible. Okay, so it's like it's also inspired by the human's neuron. Okay, suppose wherever you are sitting now, you may not feel that there is some air, but you are basically sitting the below of the sea of the air only, right? You have the air definitely, but if you switch on the fan, when the air flows up to a certain with a certain speed, then you can feel, because your neuron will get that activation that time. That time it will let you send the signal to your brain. Otherwise, you are always sitting on the air, but you can't feel. So similarly, here we have the transfer function or activation function. When a certain field will be achieved, on a certain threshold will be achieved, then the neurons will be activated in different ways, and it will give you different outputs. So if it is like a cyclone is there or a fan is going on, your neurons will be giving you different feelings to your brain. That's why you can understand now it's even if you close your eyes, you can understand that now its fan is running, simple fan, or the AC is running. And if it is a cyclone, you can understand differently, right? Or if it is a breeze of air outside, in a cool breeze of air near the sea beach, then you can identify even closing your eyes, because your neurons will send the certain signal to your brain based on the different threshold of the airspeed you receive. So that's how it works actually. It just mimic to the neuron, the biological neuron. So it's a perceptron or artificial neuron. It works in this way. So how this perception actually works, actually, I'll give you an example with a particular analogy. Suppose you want to go to a party, okay? And to go to party, but you'll take the decision that you will go to the party or not based on three conditions. The weather condition is one, that your wife is going with you or not, and any public transport is available or not. So three conditions you have. How's the weather? Your wife is going you or not, or any public transport is available or not. Three conditions. Based on these three conditions, you'll go to the party. So how will design this perceptron? First, try to analyze the entire thing. Suppose how is the weather determined by the variable x1, and x1 having two values, 1 and 0. 1 for when weather is good, you are definitely going. 0 when weather is bad, you are not going. Your wife is going with you or not. Let it be denoted by the variable or feature x2. The value is 1 if she's wife. If the wife is going, then you are going. Yes, and the 0 when your wife is not going, you are not going. And any public transport is available is determined by the feature or variable x3. It is 1 when the transport is available, you are going, and 0 when the transport is not available, you are not going. Yes, so the output will be any one. 1 means you are going to the party, 0 means you are sitting at home. As simple as that. Now, there is three factors are not same. So actually, I'm just telling you why we give different weight to different inputs. Actually, using this perceptron analogy, I'll explain you why we give different weights to different input. All inputs are not same. So all inputs are having not same importance. So the weights of each input will not be same. That's what the funda is behind. So here we have the suppose for you most important factor is weather. So weather is good means you're going to party, and weather is not good means you're sitting home. So weather is good, even if your wife is not going with you, you're going to the party. If public transport is not available, then also you'll book a cab and you'll go. And if the weather is not good, even if your wife is with you and you have a public transport, then also you'll be sitting at home. So weather is the most important factor over here. So whenever weather x1 is equals to 1, output is 1, as simple as that. If weather is good, you are going. You are ignoring all other factors on that case. So now we'll use this analogy. How we'll set the weight now? So W1 is the weight for the input x1. What is the input x1? That is the weather. W2 is the weight for the input x2. That is your wife is going with you or not. And W3 is the weight with the input x3. That is public transport is available or not. Yes. Now let this is now this will make it entirely clear. If this thing is clear to you, then the neural network's basic is clear to you. I can tell you with guarantee this thing. So let you yeah.
Sorry to interrupt you in between, sir.
Yeah.
So here we have taken the weather as a major factor, right?
Yeah.
So at a time, can it possible to take 2 as a major factor?
Yeah. Why not? It depends upon your situation, na? So
Okay.
I'm just giving one example of a situation. It can be different situation. For each situation, you are capable to design your neural network. Don't worry. Okay.
Okay, sir. Okay, fine.
Okay. So in this particular example, what you are having, you are giving W1. See this. This is a set of the weight we are giving, and this is a threshold we are giving. How it works. So W1 you are giving here as 6. So you're telling that if the weather is good, that value for the weather, the input weight is 6. For wife is coming with you or not, you are giving the weight 2. And your public transport is available or not, you are giving the value 2. And here you are giving 6, 2, 2. Both the weights are same. But see why you're giving W1 is equals to 6, because it is having the highest priority. If weather is good means you're definitely going. That's what you're setting over here. And here also you're giving the same weight. But how the threshold now playing that? The threshold belongs to where? I told you now the threshold is like how you determine the air, how you can close your eyes and your neurons can send the signal that it's fancy air and it is the breeze of a sea and it is the cyclone. It can have a different input because based on the threshold, based on the severity of the air flow. So here you can get that when you give the threshold is equals to 5, it means what? It means that if W1 is alone true, that is if the weather is good, then it is above the threshold, then you are going to the party. It will be classified as you are going to the party. The neural network, the perceptron will classify you as that you are definitely going, because the threshold is what? 5. Even if other 2 is also true and weather is bad, suppose W1 will be 0 now. When the W1 will be 0 when the weather is bad, right?
Yes, sir.
When weather is good, W1 will be 6. Are you getting it?
Yes, sir.
Yeah. So when weather is bad, then W1 is equals to 0. That time you're coming, wife is coming with you is 2 and the public transport is available is 2. So 2 plus 2 is equals to 4. So if you sum up in the cell body of the neuron, that is in the perceptron, in the summation function, then 2 plus 2 is equals to 4. That is below threshold 5. So even if your wife is with you and public transport is available and weather is bad, then you are not going to the party. So that's what it means. It will fire when weather is good and won't fire if weather is bad, irrespective of other inputs. So that is how you select this threshold very carefully. So this is a bad design for that particular purpose. This is a bad, the threshold 3 is a very bad design, because suppose the weather is bad, so it is 0, right? But your wife is with you and public transport is available, so it will give you the true output that you are going for the party, because 2 plus 2 is equals to 4, that is more than 3. So it will fire when either X is high or other 2 inputs are high. So this is not the correct design for this particular perspective. Understood? So this is how it works. This is how this neural network actually works here. So if you want to make this condition true, then you have to make this particular neural network's value true. So what will be the output over there in this particular neural network? Here there will be 3 x1, x2, and x3. X1 W1 should be 6. This W2 should be 2, and WN should be 2.
3.
Yes, and transfer functions threshold, how much it will be? It should be 6. Got it? Yes, sir. Yeah, that's what the basic analogy is. So limitation of a perceptron is that it can deal with the non-linearly separate data only. So it require multi-layer perceptron actually. So many many neurals we want. Just a single one can't work with that. That's what it means. So as a solution of the single layer perceptron, we have a solution as a multi-layer perceptron. Multi-layer perceptron has the same structure of a single layer perceptron, but with one or more hidden layers we can provide now. Yes, so it is known as the deep neural network. So when you come to the deep, deep learning, when you come to the deep learning, we come to the deep neural network only. Yes, collection of artificial neural networks, collection of multi-layer perceptron, collection of perceptrons. In this way, you have to think this matter. So we have 1, 2, 3, 3 layers we have now. Yes, so how it works? It works exactly the same way. For each input, we have a weight. We calculate the sum, and depends upon the threshold of the transfer function, it provides the particular output. Got it? Yes, the weight between the units are primary means of long-term information storage in neural network. I mean, in this way, the neural network can keep the information of the past, and the past to past phases, because it's already there in one of the other phases. So updating the weight is a primary way to neural network to learn new information. This is very important thing. First, sometimes we provide the random value for the weights, but slowly when you see that the classification is happening properly or not, the output is coming properly or not, then we change the value of this particular output, and then we propagate that thing in the back way, the new values of the weight, and in this way we change the values. So as you can see that here in this particular example, there is a set of inputs are passed to the first hidden layer, the activation from the first layer are passed to the second hidden layer, and so on till now you list to the last layer. In this way the multi-layer perceptron works. So along with the multi-layer perceptron, there is the deep neural network, there is a very useful concept always lies with that is backpropagation. Yes, backpropagation algorithm is also a supervised learning method for multi-layer perceptron. What happens in the backpropagation? Basically, what happened with the backpropagation? What the name implies is as same as that.
Sir, if any error found to be, that error will go back and as early as much as possible, it will minimal the error and it will give the appropriate output. Yes, the goal is to minimize the error. So multi-layer perceptron works on basics of the deep learning and feed-forward networks. Multi-layer perceptron works on what purpose? Feed forward. It is feeding forward. So the layer 1 output is going to layer 2, the hidden layer 1 output is going to hidden layer 2, and so on. Correct, na? So that thing may be coming as a wrong. At the end, it may generate a wrong classification. So each perceptor in a multi-layer perception connected with other. So it's first we what we do, randomly assign the weight. Correct, na? Now we have to check the correctness. So the correctness, we use the backpropagation. As simple as that. So supervised learning method for multi-layer perceptron always deal with the backpropagation. So you can't basically ignore backpropagation. Just feed forward networks. Feed forward neural networks doesn't work in today's world at all. In each and everywhere you can see that the backpropagation is used. So what happened, that weights and errors are related always. The more wrong weights you are assigned, the more errors will get. And the most accurate weights you will provide, the least errors you will get at the end. Yes, the neural networks, it will update the weight such that less error comes and correct result is obtained. Are you clear? That's the motto. Yes, that's the motto. What was the motto of backpropagation? Update the weight such that less error comes and correct result is obtained. It is known as the global loss minimum. So you can remember these terms, known as the global loss minimum. Adjust weight till least error happens. This is our strategy. This is the ideology in backpropagation. That is the global loss minimum. Adjust the weight in such a way that till lowest error happens. Yes, are you clear, guys? Yes, sir. So there is actually limitations of feed forward networks that is solved by the backpropagation. Yes. So we'll see that how to train a neural network. It is very simple actually. Yes, you can see that a particular neural network input and output is given to you. That input and desired output. Yes. Yes, so I'll show you why backpropagation is required actually. Yes, suppose this is there. Okay, this is the input is 0, output is desired output is 0.
For desired input 1, desired output is 1. For desired input 2, desired output is 4. Now you see one by one. The model output we got with the weight 3, we set the weight is equals to 3. We set at the first randomly the weight is equals to 3. Now what we see that for weight is equals to 3, we got the model output. Desired output is 0. You got the model output is also 0. Wow. So it is working very correctly. W, that is the weight is equals to 3 is working well. Now you change it. How you change it? You change, sorry, you make it 3 only. Now you see for the input 1, desired output is 2, but the model output you are getting is 3. So you are getting a wrong output, correct? Na? For model,
yes, sir.
For input 1. For input 2, desired output is 4
6.
and the model output is coming as 6. So here also there is some error. So what is absolute error? Absolute error is model output minus desired output. Plain. So 0 minus 0 is equals to 0. Now here it is also absolute error for the input 1 is equals to 3 minus 1 is equals to 1. Absolute error for input 2 is equals to 6 minus 4 is equals to 2. Now we use square error also. We'll square this value. So 0 and 1 square is the same value. The value of the absolute error 2 is equals to 4. So the more, so you can understand that the larger the neural network and the larger the number of the hidden layers are there, if one minor mistake or a small error is there at the beginning in the setting the weight, the error will be keep on increasing. Understood, na?
Yes, sir. Yeah.
So now we can see that we'll give the update the weight value and make it as 4. So if you make it 4, you can see that you are getting the desired output was 4. We are getting now, sorry, desired output for input 1 was 2. We are getting 4. It's too much difference is there. Desired output for input 2 was 4. We are getting 8 with the weight is equals to 4. So how much difference we are getting? The square error difference. See this now. The most wrong we are making in the difference in the weight, the more differences we are getting. See now the square error is more higher. Now the error is 4 and 16. So as you can understand that the input, that weight should be very correctly set. Are you clear? So how to understand? Then the question is how we'll set the weight? It cannot come from the intuition to your mind, right? So how can understand that which particular weight to be set? So for that we use this particular mechanism. You can see that on the right hand side, what is there?
As the weights are increasing,
you keep on increasing weight, and keep on recording that how it's happening, and then in certain position we get the least difference, and then we decrease the weight. Wherever we get the least absolute error, that we fix as the most correct weight. Got it?
Yes, sir.
In this way only we recognize the faces and the signatures and all automatically by the neural network. There's the formula for that. I'm not going through in detail all these things. We'll just learn first the limitation of feed-forward network. So what happens, a trained feed-forward network, it can be exposed to any random collection of photographs. And the first photograph it is exposed to will not necessarily alter how it classifies the second one. So for example, you are giving a lot of the images over here for this neural network. It will output as T. This elephant is output at the time T. And the output at the time T minus 1, we got a dog. But there is no relation because it can't recall anything which has happened in the last phase or in the last hidden layer. So each output, listen very carefully, the limitation of feed-forward neural network is that each output is independent to other. But that's not the real world scenario. In real world, suppose you are reading a book. Each pages are not independent there. Each pages are dependent. Each pages having a character. That character did something in the last page that is continued to the next page. But if you want to classify the that particular book story by using the feed-forward neural network, you can see that it is dealing with all the pages as independent. So it cannot be used when an outcome is based on previous outcome. I repeat, feed-forward neural networks cannot be used when an outcome of a certain layer is dependent and based on the previous layer outcome. Yes. So how to solve that? Then how to solve that? See this thing, what I told actually, you are reading a book. So in each and every phases, they are giving you a different response. But it's not true actually, because last response you should supposed to know to have a next level response because it's connected. Yes, so output at T minus 1 should be understood by the output at T. They should supposed to know that what was the last phase problem. Are you clear? Yes, that is being done. That is solved by the recurrent neural network. So what is recurrent neural network? It's a type of artificial neural network designed to recognize pattern in sequence of data. So it understands the sequence, what happens last and what's happening now. Such as you are reading a text or genomes, genome structure, last structure and now structure, it understand. Handwriting, it understand that how you wrote last time A, or how you write last time TANVIR, how I write my name last time and now it understand that. The spoken word, it can understand how you spoke in this situation. The numerical time series data, like suppose, for example, stock market data, it has to understand the last phase. Then only it can determine the next phase properly using the neural network. Yes, the data which is emanating from different sensors, stock market, government agencies. So it should supposed to be understand. Otherwise, the neural network can't, predict and suggest you the proper thing. For example, suppose you are going to gym. Okay, the gym is very popular now, and most of you go to the gym. Okay, so that example is provided over here. Suppose your gym trainer has made a schedule for you. The exercises are repeated after each third day. So today you do biceps, tomorrow you do shoulder exercises, and next day you do the cardio exercises and all these things. First day here you do the shoulder, and next day you do for the biceps, and next day you go for the cardio. So how to predict that when you're doing today something, how will do tomorrow? By using the feed forward. If you use the feed forward network, if you provide the date, a day of the week, you can understand that, okay, biceps will be there for today. Month of the year, it will be, okay, today is cardio. As a health status given, it should supposed to be, shoulder exercises and all. Yes, but it can understand that what you should supposed to do based on yesterday or all these things. By day it can understand, by month it can understand, by health condition can understand, but it can't take the care of your yesterdays, the last day. Yes, you have to understand using the previous days based on the past information, past input. You have to predict the future. Nah, that's the requirement now. So you have to use the recurrent network in this way. So how will you use the recurrent neural network now? If you use the recurrent neural network, it will use the feed forward networks, these capacities, along with the yesterday's, this shoulder of yesterday, which exercise you do, biceps yesterday what you do, and cardio yesterday what you do. And you can use the last session what you have predicted, that also you can use as an input. So predicted shoulder yesterday, predicted biceps yesterday, and predicted cardio yesterday. Based on, you can give the predictions that for this particular thing, you can go for the shoulder exercises, you can do the biceps exercises, and you can go for the cardio exercises. Yes, this is what it happens for the recurrent neural network. So you can see that it can feeding forward also, and you are taking the old information and also the new information for predicting the current one. This is the recurrent neural networks use. Yes, so we will now go into the convolutional neural network. So what is the convolutional neural network is? We know that each and every images, like you have an image over there, each image is converted to RGB, right? Red, green, blue values, correct? Now we have lots of pixels. So for each pixel, we have the value of the pixels, and we have to determine the size of each and everything, suppose. So can you tell me that how many neurons are required at the first phase? Many neurons will be required for each pixel. For each pixel, at least one neural will be provided in the first phase. At least the initial phase neurals should be as many as that. Then you think that what will be the next year, in the next hidden layer, on the next phase, it will be more than that. Then what will be the next level? More than that. This will be like too many will be there. For this kind of image recognition, you cannot fit the entire image and process so easily by using the recurrent or last whatever the neural network you have taught till now. So the problem will come as the overfitting. It will be overfitted to your particular computer. It cannot be processed well. So see this images with 22 into 22 into 3 pixels. So how many? This many amount of 2352 number of weights should be provided, and neuron should be provided for that. Now with the image with the higher higher resolution, will be having suppose 200 into 200 into 3 number of pixels. So that many amount of layers will be there, and that many amounts of hidden layers will be there. So it will be like overfitting will be definitely happening. What's the solution? What's the solution for that? So we don't need fully connected neuron, because all the output of the axons, like all the connected, each and every layers neurons are all connected. Each neurons will be giving the output to all other inputs, correct? That's how it works, correct? So we don't need that. That's what we don't need. That's what we don't need. We don't need now fully connected neurons. It will be creating overfitting. So what's the solution? What's the solution? Listen very carefully. Only significant neurons will be connected. Only the particular neurons which you feel like significant will be connected only. So in case, that is known as the convolutional neural network. In case of convolutional neural network, the neurons in a layer will only be connected to a small region of the layers before it, instead of all the neurons in a fully connected manner. So overfitting issue will be solved in this way. So this is basics about the neural networks. Okay, because I actually focused on the machine learning, but I just wanted to complete this part also, neural network part also. Is it fine, or do you have some doubts on that? I think some other lecturers have also covered these topics, correct? Yes. Can anyone speak, please? Arati?
Yes, sir. To some level, different levels.
Yeah. Plus tomorrow, I think another lecture is there. There also neural network types will be covered again. So I have not given much focus on that. I have tried to give more focus on machine learning. Okay. Now today we'll have some session, practical session we have, right? So we'll be learning something practical on machine learning. We just want to machine learning is anyone has taught you anything? I mean, any Matlab presentation has happened on machine learning? I don't think so.
No, sir.
No, right? Okay, fine. So one machine learning algorithm I'll teach you from the beginning, from the scratch. If possible, two algorithms also, if time permits, I'll go through with 2 algorithms. But I think it will be better to concentrate on one properly and execute something. Okay, if the time permits, then I'll go through with the true. Okay, but I'll go through slowly and I'll make sure that each and everyone can at least understand a single topic clearly. That should be my first motto. Well, sorry, let me share the screen and go through with the first example. Well, so this is the topic here. We'll be learning unsupervised machine learning. Yes, now we'll be learning about how to learn. We'll be learning unsupervised machine learning with a particular algorithm. There are many algorithms for unsupervised machine learning. One of that is KMeans, and why I'm choosing KMeans is that it's one of the most popular algorithm for clustering. This clustering, as I explained in the morning session, that clustering itself is an example of what? Itself is an example of unsupervised machine learning. All clustering jobs are unsupervised machine learning. In case of clustering job, we just see the property among the data types. So we see that this data belongs to what, and this data belongs to what. What are the features for this data? What are the features for this data, and how these data are interconnected? We find the similarity between the data points, and we find that data x1 and x2 are similar. We put them into a single group, and we see that the data y1 and y2 are similar. We put them into the different groups. That's what's the clustering, correct? Yes, the clustering can be implemented using, there are maybe dozens of algorithms are there, and 5 different techniques are there for clustering. I'm not going to go to all those things. It will be too much time consuming. So what I'll go through with that, I'll pick the most widely used, most popular, but most simplest algorithm for clustering. That is the K-means clustering algorithm. And I'll first explain the theoretical aspect of the clustering and K-means algorithm. Then we'll go through with the Matlab and execute an particular, example using the Matlab for K-means algorithm. Okay, so in this way we can have some hands-on session also. Well, so we'll start with that. So what do you mean by unsupervised learning? In unsupervised learning, what happens? In unsupervised learning, it's the self-learning on the data. Yes, it can be thought of as a self-learning, while the algorithm can find previously unknown patterns in data set that does not have any sort of labels. So that thing has been explained in the morning session. So I'm not going to go into much time over there. So unsupervised learning is like the data is not labeled. You don't know the output of the labels. When this data belongs to which particular output can provide. You just randomly go with and read the features of the data and group them together. That's what the unsupervised learning mechanism is. So it's opposite to the supervised learning. In case of supervised learning, you know the data. You know the data already. You know that this is apple and this is banana. Yes, in unsupervised learning, that apple and banana is given to you. They have not told you the label. This is apple, this is banana. So you don't know that for which feature this is known as the apple and for which feature it is known as the banana. But you see that the banana, it looks different. Apple, it looks different. The banana's color is different. Apple's color is different. Banana's texture is different. Its shape is different. Apple's texture is different. Its shape is different. So you gather all the apples together and you gather all the bananas together. But still you don't know this is apple and this is banana because there was no labels. Only the user who has done the clustering, after that he can name that, okay, these are the apples will be named as apple and this will be named as banana. It's up to him. But you don't, because you don't know the apples and banana by yourself. It was not labeled. But that is what the difference between the supervised and unsupervised learning. So if you have any doubt on unsupervised learning, then please let me know. Anyone has any doubt on supervised or unsupervised learning?
Sir, can you once one more time, can you repeat it, please?
This same example, sir, can I repeat, sir? I mean the fruits example.
Yes, sir. Yes, sir.
Okay, sir. So it's like, suppose you are going to a you have gone to a fruit shop. So there is the fruit stalls is there and many different types of basket is there, and in different basket different fruits are kept. So in one basket there is apples, in one basket there are bananas, in one basket there are papaya, in one basket there is jackfruits, and in another there is, suppose you have strawberries. So also it's actually, if I write it will be better, then I can keep on repeating the same thing. Sir, hold a minute. Okay, so let me write down this. What are the things that there? We have apple, we have banana, we have jackfruit, and we have strawberry, and we have also I think what else I told, papaya, na? Yeah. So these are the fruits you have. Okay, these are the fruits you have found over there. Okay, now just to imagine that thing is not there in the fruit stall, rather it's there in the data. Okay, it is there into the data. Suppose is there into the image. An image is given to you with many apples, many banana, many jackfruit, many strawberry, and many papaya. Are you clear? Now, in case of unsupervised learning, what will be there? Beside the image, it will be written as banana. Beside each and every image will be labeled, sir. So beside the banana, it will be labeled as banana. Beside that apple, it will be written as apple. Behind the jackfruit, it will be written as jackfruit. Behind the strawberry, it will be written as strawberry, and behind the below the papaya, it will be labeled as papaya. So each and every fruits are labeled to you. Each and every fruits are labeled. So you basically know that which fruit is named as apple. So now you read that when the color of the fruit is red and it is having this kind of shape and this kind of texture, it is equals to apple. Now you also learned from the image that when the shape is this large kind of and the color is yellow, it is banana. When it is it is reddish and it is a big one, it is the papaya. And when it is very large, when it is very large and it looks like in the body there is lots of small scattered kind of thing, it is jackfruit. And when it's a very small and this small size and it looks like in this way, it is strawberry. So already you read that for this feature it becomes this fruit. For these particular features So the value of the features is this, then it is apple. If the value for the features is this, then it is banana. For the value of this features is jackfruit. For the value for this feature is strawberry. For value of this feature, it becomes a papaya. So you know the labels. So you know the labels. Now, whenever a new fruit is given to you, suppose I have given you a new image. That image is fed to you. Now you fed that image to your neural network or to your machine learning software, whatever it is. I've fed it to you. Then your system will see that is the color is red. Yeah, the texture is the color is red. Is the texture is equals to apple, matching like an apple? Yes, 97% matching with the apple. Is the size is matching with the apple? Yeah, 98% matching with the apple. Then equals to, then it will classify it as an apple. Now you feed a new, now you feed you with another picture, another image. That image now you go through with the machine learning model algorithm, classification algorithm. It will see that, okay, this is having the color is equals to red. Okay, the texture is matching to wood, or the texture, the values of the texture is matching 95% with the strawberry. The size is matching. Yeah, size is matching 95% with the strawberry. So the most closest match is the strawberry. So that image becomes the strawberry. Similarly, you can classify papaya, sorry, papaya, jackfruit and banana. Yes, because you know that for this particular values of the image, it goes to the this particular output of the label, that particular label of output for that particular fruit. Am I clear to you, sir?
Yes, sir. Yes, sir.
Yeah. So that has become the classification, and it is known as the supervised model.
Yeah.
Yes. Now an image is given to user. A lot of the fruit image. These 5 fruits are there in the image: apple, banana, jackfruit, strawberry, and papaya. But they have not labeled it at all. There is no label on that. So you don't have any idea which fruit is known as what. You have no idea. Randomly the fruits are there to you. The images is given to you. Now your machine learning algorithm is trying to get that particular, fruits, and you have been told that you group the fruits based on their similarity. You gather the fruits together with the similarity. So basically your objective here is to group apple separately, banana separately, jackfruit separately, strawberry separately, and papaya separately. So all these different fruits you have to gather separately. But how will do that? You don't know what is different fruits are there over there. There is no labels. So you start with the data. There is no supervision. No one is guiding you. The only guiding you can get is by getting the features from the data. The features also you have to learn self. First you go through with that. These many colors I'm getting. What are the colors? Okay, I'm getting red colors. So along with red colors, these are the size matching, and these are the size not matching. And there is 2 big fruits. One fruit is papaya, which is having a very plain body. Another is the jackfruit. Their features is different. There is having clustered body. The body is having lots of hazy surface on it. Yes. So in this way, you are learning from different fruits. And at the end, you are gathering that, okay, these fruits are having the same features. So these are in one group. This feature, so apples you gather all together in a one group. Then bananas you gather together in another group. Jackfruit you gather together in another group. Strawberry you put into the another group, and papaya you put into the another group. How? By seeing the size, texture, color, and all these things. So this has become the clustering. So if a new example is given to you, suppose a new image is given to you for the apple. So now you'll see that with the existing group, which particular, I mean, for each cluster, now there will be 5 clusters. So the output of the unsupervised learning here, it will be clustering, right? So 5 clusters are groups. So 5 different clusters will be created. One cluster is apple, another cluster is banana, another cluster is jackfruit, another cluster is strawberry, another cluster is papaya. So 5 groups of the fruits are created. Now, if I give you the next image, and if I tell you to cluster, then each of these particular groups will see that how much similarity we have with this particular fruit, and they will add that particular fruit to that particular group based on the similarity. So that becomes the clustering job, unsupervised learning. Is it clear, sir? Hello. Dr. Art Santanam. Can you hear me?
Yes, sir. I'm hearing. I'm hearing, sir.
Is any doubt? Is any doubt? Is it clear,
No,
sir?
sir. No, sir. No, sir.
Okay, sir. Thank you, sir. So let me give another example provided over here. So for example, we have, suppose you and your friends want to watch the cricket match, but you do not know what cricket is. But for your friend, you say yes. You reach home and start watching the match. Now you're learning by unsupervised. No one is teaching you, okay? No one is teaching you what is this and what is that. Yes. So now you're learning one by one. How you're learning? Srivatsa, are you asking anything?
Yes, sir. I have a small doubt here.
Yeah.
So I want to understand. I mean, I have been through your class, but I just wanted to understand what exactly is a model and what is the context here. I mean, how do you define a model in this context? So that is what I'm really having a hard time to understand, sir. Like model in layman terms and in example.
So
for
you're
example, yeah. Sorry, sir.
Yeah.
Please.
Yeah, basically you're telling that how we'll create the machine learning model here in this particular case.
Yes, yes, yes. And before that, can you explain model in layman terms so that I can understand it better?
Sir, model is nothing but when you create a particular machine learning, you have to first find that which particular machine learning algorithm it should supposed to work on. Supervised or unsupervised or reinforcement. So here you find out, suppose it's a supervised learning method. So now you have to go through with the algorithm, which particular algorithm will suit over there. All the things come into the model. You are modeling the thing. Okay, so you understand that this particular algorithm is suitable for that. Based on your the more experience you'll get, the better understanding you'll get. Now that particular algorithm can have different parameters. So you have to understand that which parameters will work for this particular thing. Like for this example, just I gave that for jackfruit, and what the fruit I told, apple, banana, jackfruit, strawberry, and papaya. So based on your experience, you can say that the groups will be based on these 5 algorithms. These 5 different groups will be there. And based on your experience, you understood that, okay, K-means can be executed for that. Or some may say that no, K-means will not be so good for that. Fuzzy C-means can be used for that. Few may say that no, fuzzy C-means will be not so good. We can use K-medians for that particular. So we have different algorithms. So choosing of the algorithms comes into the model. Now choosing of the algorithm is also not sufficient. The algorithms can have different parameters. So you have to understand that which particular parameter to be selected for that. Suppose for K-means, you should supposed to understand that we have to select randomly centroids. So that's another big deal, that which particular centroid to be selected. Is the centroid should be unique or should be from the same data site? If the data site is scarce or not. If the data is not scarce and data is very dense data, then the data centroid selection can be used by particular optimization technique or not. Or some particular other techniques like a swarm optimization technique can be used for selecting the centroids and all. So all these things comes together the model. After optimizing, after selecting the particular algorithm and their optimization techniques, which can only grow over the time based on your experience. At the first, you cannot create a proper model. You have to just take an algorithm and execute. That's it. Okay, so you understand now, you have been experienced now with the machine learning, you keep on working on machine learning, and then you got to the particular algorithm. Now the algorithm has to be modeled for a particular data set. The data set is not sufficient. I mean, different data set works differently for different kind of algorithms. Suppose for K-means, numeric data set is very much suitable, but if there is a noise, on the data, suppose K-means you're using K-means algorithm, but the data set which you got, it has lots of noise. Noise means what's unwanted data. So you have lots of unwanted data over there available. So that unwanted data, the noise will be having a very negative impact on the K-means algorithm. So either you can use fuzzy K-means on that time, or you can do one thing, you can use the noise removal method incorporated in the K-means algorithm. So in this way, you can optimize the K-means algorithm. After that, you see that with a particular test data training, you can train the algorithm by using a part of the algorithm and see that how it is working, what's the efficiency it is giving. Now to judge the efficiency of the K-means algorithm, you have to use there are many measures for that. One of the measures are Silhouette measures, we have the Dunn measure, and we have the Davis-Baldwin measures, we have the Fukuomo-Sugeno measures, and we have Zai-Beni measures. So we have many measures. Using those different measures, or you can use the majority voting technique by taking many measures altogether. You can see that which particular data set is matching with the K-means, and then for that particular data set which you have obtained, for that you can determine, should I supposed to use K-means, or should I go for the K-medoids, or should I go for the fuzzy C-means. So in this way, you are modeling the entire machine learning thing.
So if I understand it right, I think if we are beginning, if we are entering the world of this machine learning, I think it's more of a trial and error at the beginning. However, if you gain more experience, you will be able to aptly judge the algorithm.
Yes, sir. Yes, sir. Even deep learning is trial and error, sir. We have to trial and error with the weights.
Thank you, sir.
Weights and bias also, neural network also you have to go through with the trial and error. Yes, it's true. The term is very true, sir. Yeah, trial and error you have to go through. Oh, Soumya, madam. Okay, madam. Okay, I'll make you co-host.
Thank you, sir.
Is it working, madam?
Thank you, sir. Yeah.
Well, so any other doubt with that? Because it should be very clear. Otherwise, there is no point of going to KMeans and explain. Guys, dear participants, it should be very clear to you. Otherwise, there is simply I'll go through with the Matlab, I'll execute some code, you'll see, that's it. And if you understand the algorithm KMeans, even if I don't teach you Matlab, you can get the Matlab code. I can just tell you that how to search. You can get many Matlab code in MathWorks. You can execute your own. So that's the difference between understanding and just simply participating. So I'd like to ask you for any doubts. I'll be happy if you ask me doubts.
Yeah, till now it was clear.
Yeah, Prakash, you're telling something, but it's echoing much than I can hear.
Oh, no. Till now it was very clear.
Okay, it's clear. Okay, so thank you, sir. So if anyone else having any doubt, can please you can put into the chat box also. Because these basics should be very clear. Then I'll go to the KMeans, and KMeans should be very clear. Then only practical can happen. Otherwise, you can do practical at home also. The concept should be very clear to you. That's what I always insist on. You can put into the chat box. I can wait for 10 more seconds. So, well, guys, I hope that you understood all the concept till now. So here we are just, okay, someone put in the chat box. I feel like better go in your way. Okay, fine. Well, so here you're learning about the cricket. Okay, no one has taught you about the cricket. You are learning your own. What's cricket actually? How cricket can be played, and what the hell the cricket is actually. You're learning here. So you do not know what's really happening and just sit blank. But looking at your friends, you want to join the fun. So you start learning about the cricket. So how you'll understand that? How you'll understand about the cricket now? You come to certain conclusions after watching over there, after watching a match. So there are two teams. One is the India and Australia. The different kinds of players, such as batters are there, bowlers are there, and fielders are there. And a few people come for taking the waters and all these things. And a physio is there. You understood those things. Now, you understand that the ball hits the wicket or is caught, the batsman is out. So when the ball is hitting the wicket, surpassing the bat, or if the bat hits the ball, but it is caught, then the batsman is out. And there are people cheering when India scores a 4 or a 6. So you understood these things by watching the game. Yes. Are you clear? So this is the unsupervised learning. So you're understanding by seeing the different features into the game. No one is teaching you, but you are not also learning blindly. You are using your brain to learn. You're using that. Okay, India is having this color jersey. So the people who are having in blue jersey, they're Indians. The people who are playing with the yellow jersey, these are the features, right? Your eye is reading actually. So that can be done by the machine to machine learn. That will be machine learning. So your eye is learning, the same thing should be learned by the machine. That's it for the machine learning. For that, you have to choose a method and an algorithm and train that. So you're seeing that, okay, yellow jersey is played by the Australian team. Okay, so when it becomes 4, when the ball is, the feature of the ball is that the ball should supposed to touch the ground before the boundary line, it becomes a 4. Otherwise, it will become the 6. Yes, you understand that there are some batters and these are the features which make a batter out. And you understand these are the bowlers, and this makes the bowlers having a white ball or a no ball or a wicket taking ball or a bouncer or a yorker. You understand each thing by seeing the different features. What's the feature here? Where the ball stuck, based on that. If it is a wide, it is seeing by using a particular value. Yes, the value is that this particular touching into the into the wide, that particular line is there over there. It's a wicket taking ball when it is hitting the wicket. It's a it is a bouncer when it is going up to that level, up to the level of the shoulder of a batsman. It's a yorker when it's got exactly to the bat and just behind and below to the bat. So you're understanding by using the value. Your eye is reading and sending to your brain, and you're understanding in this way. The same thing can be happened in deep learning and machine learning. So this is what the clustering job is. Yes, so this is what the clustering job. What is the clustering job here? In clustering job, we understand that the data is not labeled, but by selecting the correct features among them, by seeing that the similarity between features, we put them together. So oranges are put together by seeing their color and texture. The apples are put together by seeing their color and texture, and the strawberries are put together by seeing their colors and texture. So the same thing we can do by our own eyes, right? If you tell you that you've given 5 fruits, please gather together the unique fruits. How will you do it? The fruits you will be seeing by using color and texture only, right? You might not even use your hands to touch and send a signal to your brain. You just your eyes will be sufficient for that, I think. Yes, correct, right? So similarly, by seeing the color and what your eyes is reading, actually color and shape, only 2 features, and they're having certain values which your neurons are sending. The same thing can be done by the machine. That will be machine learning. Yes, there is another example of unsupervised learning, that is association. In association also, we unsupervised. No one will guide you, but you will learn it. How will write? By using the association. You see the associativity between 2 people or 2 items or 2 things. For example, in the morning, I gave the example that if a person is purchasing bread and butter, okay, then we can understand that there is an association would be with the milk. So you can understand that these 3 things will be purchased together. Many people will purchasing, suppose, bread, butter, and milk together. Bread, butter, and milk all together. So what you understand that there is a association between bread, butter, and milk. So if a person just purchase bread and butter and don't purchase milk, you can recommend him that please purchase milk. You might be missing it. So that is known as the association rule mining. That's a part of the unsupervised machine learning only. But here, as we are going through the K-means only, you will focus only on the clustering. Because K-means is a clustering algorithm, not an association rule mining algorithm. Okay, so we'll be learning about the clustering only now. So what is clustering? Clustering means that grouping of object based on the information found in the data only. Describe the objects or their relationship. So you can understand that based on the information found in the data. So it's not labeled data. The goal is that objects in one group should be similar to each other, but different from objects in another group. So in a single group, the object should be most similar, and the data in the object in the different group should be as dissimilar as possible. So like the papayas in one group are having the most similar features, right? And apples in another group will be having most different features among papaya and apples. So it deals with finding a structure in a collection of unlabeled data. So you find a structure. How you find the structure or relation, in a collection of unlabeled data by using what? Features. How we'll get the features? By using in real world, by using the variables. In the data, we'll be having the variables. The variables may be general variables or might be the image pixels that we do in deep learning, right? Image pixels for image processing, we do what? Image pixel we take as a standard for the same thing. So what are the examples of clustering algorithms? Fuzzy K-means and hierarchical clustering are the most popular one. K-means is a hard clustering method. Fuzzy clustering is a soft clustering method, and hierarchical clustering is the clustering method which will output the data in a hierarchy. It will try to find the hierarchy between the different data. So suppose you are going to cluster the Jain University data, then you may choose that hierarchical clustering. Then it will keep you the hierarchy. Students are there in different departments. It will provide hierarchy for different departments. Then the faculty in different departments. Then the placement in different departments. Then the management in different departments. In this way, it will gather the data. This is what the example for This is the example of the clustering methods. So hierarchical clustering and fuzzy C-means clustering algorithms are quite difficult than the K-means algorithm. I think the most simplest and most widely used algorithm is the K-means algorithm only, K-means clustering algorithm only. So that's why I chose here, as is the first class for you, to learn a single algorithm. Just learn, at least learn a single algorithm. Otherwise, I can go through with the fuzzy algorithm also next. But I don't think the time will permit. It's already 3 almost. So we learn a single algorithm properly to solve a problem. You solve a problem in your own. I'll give the problem to you. You have to do your own. Then I'll be explaining a bit more complex problem than that by using Matlab. That is the objective of this particular class. Yes. So K-means clustering will go through one by one. Let's see. What is K-means clustering? What is the K-means? So there is a name, na K-means. So what is clustering? You understand? Clustering is a part of the unsupervised learning. What is unsupervised learning? You also understand. That's the part of the machine learning. What is machine learning? You understand. That's the part of the artificial intelligence. Now we are into the a bit depth. So from artificial intelligence, we get to the machine learning. From machine learning, we go to the unsupervised machine learning. Unsupervised machine learning, we choose an algorithm, a technique clustering, and in clustering, we choose a particular algorithm, K-means. So now we learn about what is K-means actually. So we are going to actually into the particular level actually. So this is where we'll work actually. When we work, we go to that depth. Okay. So it's not a theory, it's practical. We're going through the theory to practical now. So what do you mean by K-means algorithm? So there is a name K-means. K-means. So the name has some definitely some importance, right? Some implication it has. This name is not given simply. Some meaning it has. It carries some meanings, right? So K-means. So K stand for number of clusters, the number of groups. So in this example, which I gave it to you, it is having 5 groups: apple, banana, jackfruit, strawberry, and papaya. So this in this particular example, K means 5. K is equals to 5. Means it use a particular calculation which is based on the mean. There are 3 types of calculation widely used. Okay, one is the mean, median, and modes. What is the mean actually? Suppose I give you the value. Suppose let me use the pen. I'll give the value 11, 9, 8, 13, 2. So what will be the? Okay, I'll give a better example. I give the value 1, 4, 4, 8, 6. So 1, 4, 4, 8, 6. Okay. So what will be the mean value of that? The mean value of 1, 4, 4, 8, 6 is that 1 plus 4 plus 4 plus 8 plus 6. All the values will be added, divided by the number of items. That is how many items is there? 1, 4, 4, 8, 6. 5 items divided by 5. So what will be the value? 1 plus 4, 5 plus 4, 9 plus 8, 17 plus 6, 23 by 5. So what is the mean value? 4.6. Okay. So 4.6 is the mean value. 4.6 is the mean value. That's the calculation. So when you go through the K-means, surely you are going to do something with the mean value calculation. So just keep this thing in mind. So, okay, when I go through further, definitely I'll explain each and everything of that. But before that, just to go through with this understanding, K is for the number of groups which are going to create at the end, and means for the calculation. The way how we'll calculate how to find the number of groups, how we'll calculate by using the means calculation. So means is calculated in this way. How the mode is calculated? Mode is calculated by the median. Median is calculated by the median value. So you have the value 14486. What is the median value in this shorted array? You can, if you short it, what will be the median value? The 4, because there's the median. There are 5 items, right? 1, 4, 4. If you short it, 6 and 8. So what is the medium item? Medium item is 4. So that should be the 4 will be the median value. What will be the mode? Mode will be the most occurred value over here. The most occurred value here 4. So 4 will be the mode. Okay, we are not going to mode and median. It doesn't mean actually here. It's meaningless to think about the median and modes over here. We'll just focus on the eye of the bird. That is the mean. What is the mean? So given n number of values to you, you add the value and divide it by the number of the objects. You add n number of objects divided by n. That becomes the mean value. Yes. So something we are doing with the K and means. Something we are doing with the K and means. K is the number of groups and means is the calculation. So now what is K-means clustering? K-means clustering is one of the simplest algorithm which uses unsupervised learning method to solve known clustering issues. So how we'll do it that? How will do it that? It will first divide the entire data set into K cluster. That's the first step it will do. Yes. What it will do? It will divide the entire data set into K cluster. That's the output. That's the output it will obtain. How it will work? How it will work? K-means clustering require 2 inputs. First, to work with that, it requires 2 inputs. What are the 2 inputs we have? The first input is the number of clusters that you have to give the input. If you don't give this input, the things will not work. Keep this thing in mind. A K-means algorithm requires a primary input to it. You have to give the input that the data should be divided into how many groups. So I'm giving you apple, banana, jackfruit, strawberry, and papaya. But still, you have to tell that how many groups will be there. You can give 5. If you give 4 groups, then it might be having a not so correct result. That's the problem with K-means actually. So for that, lots of solutions is also there. So that thing will not go through at the time right now. That's the research area actually, and there are many research papers available for that. We'll just go through with the particular things which you are caring about right now. So that's what we have right now. So hold a minute, guys. This thing I'll make it. Yeah. Well, so K is equals to number of cluster, and we have to give the input data set. That these are the 2 input it takes. What is the number of clusters? K, and the input data set. Input data set may be 1D, 2D, and n dimensional data. It can be anything, but it should be numeric data. Yes, because K-means works with the numeric data only. If the data is not numeric, just transform the data in the data cleaning phase. The second phase was the data preparation. On that phase, you change it and keep it into a particular data set which works like a numeric data. So on that way, you can just set it to the numeric data over here. Yes, and then feed it to the K-means. So suppose the total population is given, and you can provide it to the different groups by K-means algorithm. It works in this way. So now we'll go through with the algorithm itself. It's very crucial, and you should supposed to understand a bit of it. And I'll be very happy if you understand a bit of it over here. So the algorithm can be stated as follow. K-means algorithm. First, it selects K number of objects at random from the set of n objects. So the question is that, what is K? K is the number of clusters, right? The number of ultimate groups, the number of resultant groups. The results will be having K groups of objects. Now the question is, what is K? What is K? K is the number of groups, right? Sorry, not what is K. How to get the K? Now, how you understand that the K will be there? Then, okay, you understand that 5 Ks will be there. But how it will determine anything over there into the K-means? No. Just selecting that the 4 or 5 number of cluster will make is not sufficient. The similar number of objects you have to pick initially as a centroid or center of gravities of K-means cluster. So I'm giving you a bucket of apple, a bucket of banana, a big bucket of fruits with apple, banana, jackfruit, strawberry, and papaya. You have to select, if you want to make it into 5 different groups, 5 different fruits you have to select at the beginning. 5 different fruits you have to select at the beginning. That's required. Otherwise, 5 groups cannot be created. These 5 fruits may be 1 apple, 1 banana, 1 jackfruit, 1 strawberry, 1 papaya, or it can be 2 apples you have taken, 1 banana you have taken, 1 jackfruit, and 1 strawberry you have taken. You have not taken papaya only. That's also possible. Iteratively, it will get it correct. Iteratively, one by one, step by step, it will rotate. K-means algorithm works in rotations, iterations, like for loop has iteration, right? K-means algorithm has iterations. So it learns itself by using iterations. So as you're telling, machine learning algorithm learn from the experiences. So how it will learn from the environment and experience? So I'll tell you by using K-means iterations. So first we'll choose K number of objects randomly from the n objects. N objects are the input. N objects are the input. K objects you are taking as a random. That is what? That is not the input. That is the initial cluster centroid that you are selected, K. Now for each of the remaining object, it is assigned to one of the closest centroid. Thus, it forms a collection of objects assigned to each centroid, and it called a cluster. It's very important actually. So I've given a bag of fruits. You have taken 5 fruits randomly. So to create 5 groups, 5 fruit groups. Okay. Now from each fruit groups, these are the known as these 5 fruits, 5 particular fruits is known as what? Is known as the centroids or cluster centers. 2 terms we use, either centroid or cluster centers. So I'm using centroids here. So I'm keep on using centroid here only. Okay. So we have selected 5 centroids. Now from each centroid, we'll see the distance similarity with all other fruits. So suppose papaya you have taken. So with papaya, we see the similarity with a strawberry. Another centroid is apple. Apple will also see the similarity with the strawberry. So apple will find the similarity 0.4 and you will find the similarity 0.2 because papaya is too far from the strawberry, 0.2. And there is another centroid, strawberry only. Strawberry will find 95% similarity with the strawberry because it's completely same almost. Correct? Now maybe the size will be a bit different than the centroid chosen strawberry, but it's still a strawberry. So size will not be different so much. So 95%, 97% will match. Are you clear? So in this way, for each centroid, we'll search all other fruits and whichever is the most similar one, we'll gather it to that particular group. So you can think it's that there is a bucket. This is the bucket in front of you. Just to imagine there is a bucket of fruits in front of you. You have taken, you just want to group by using KMeans 5 different groups. The fruits should be grouped into 5 different groups. So 5 fruits you have taken randomly and put into the on top of your table. Now you're taking one fruit from the bucket and seeing that which one is the most similar with which centroid. So if it is matching with the strawberry, you're keeping with the strawberry. Next fruit you took, it is matching with the papaya, keeping with the papaya. Next fruit you took is matching with the apple, keeping with the apple. In this way, you are gathering all together. Okay? Yes. Now the question is that how can I understand this similarity? How to understand that two fruits are similar? By using their features like the variables, like the size, texture, and all these things. But how do you do in practical? You do by using distance calculation. That is known as the distance measures, which you use in data mining. One is the Manhattan distance, another is the Euclidean distance, one is the squared Euclidean distance. All the things I'll be, if I go through the practical, that time I can explain it to you. So there are different ways to calculate the similarity between two objects by using the distance. The least distance we have, the most similarities. Or we can write down the algorithm in such a way that the most distance it has the most similarities, also possible. But in general, least distance has the most similarity it has. So selecting the distance measure is also very crucial. It is very important for a clustering job. And as I told now that this is the part of generating the model. Someone asked me about the model, right? So all those things are the part of the model. Selecting the key, selecting the proper algorithm, selecting the proper, the measures, distance measures, which will use all comes to the part and parcel of the model creation. After that, you got a group, correct? Next, the centroid of each center is then updated by calculating the mean value of attributes of each object. Now you select the mean value for each. So the clusters are there. Now all apples are there. Now you calculate that mean value of the texture and color and keep updated the mean value. So suppose you in one group, you got 10 apples. So 10 apples texture plus size divided by 10. You'll get a certain value, right? That becomes the mean. So that becomes the new cluster centroid. So in the next iteration, the same bucket's value will be used with the new mean values. This assignment and update procedure is until it reaches some stopping criteria. Sometimes we said the stopping criteria is that 5 iterations it will work on, or 3 iterations it will work on, or the centroids will remain unchanged. Centroid will not change. If it is very perfectly clustered, then the centroid value will not change. Yes or no more assignments will be there. That time the KMeans algorithm will stop its execution. Got it? So this is the official and formal portrayal of the algorithm. So what is the input? D is the data set consists of n objects and K is the number of cluster. That you have to fit these two things. N objects in the data set and K is the number of cluster you have to fit at the very beginning. What is the output? A set of K clusters. So as the number of the initial K will be given, based on that, the number of clusters will be generated. What's the steps? We will first randomly choose K objects from D as the initial cluster centroids. So that's the first step, as I told that, picking of initial centroid. Next is that we'll execute a for loop for all objects and compute the distance. See, this distance measure is coming over here. Compute the distance between the current object and K cluster centroids. Okay, so we are getting the distance based similarity for each object and the cluster centroid, but we'll assign the current object to that cluster only which has the least distance, that is the most similar, most closest, that will assign over there. So apple will be assigned with the apple, strawberry will be assigned to the strawberry because that will be having the most similarity. Yes, least distance. Then third step, we'll compute the cluster center of each cluster. We'll compute the cluster centers of each cluster. So this is by the mean value calculation. We calculate the mean value of each group. Now this will become the new cluster center. Now this step 2 to 3 will be keep on repeating until some convergence criteria is satisfied. It may be the criteria like 5 iterations will be there, or 3 iterations will be there, or there will be no new assignment of the object. Each and everything is done already, or some other criteria we can fetch. Actually, there are lots of optimization for KMeans. It goes for that. That's it. And in the 5th step, it will stop the execution. In this way, it will keep on adding the new objects into the groups. Yes. Now the objects are defined in terms of the set of attributes. See this A, which is the A1 to N, where each AI is the continuous data type. And distance computation, any distance such as L1, L2, L3 or cosine similarity is used. What is L1? L1 is the Manhattan distance. Okay, I'll just wait a minute. Let me explain this. Can you see my screen, guys? Can you see my screen of
yes, sir. Yes, sir.
Okay. Okay, fine. So there are different type of the measures. Okay, one is the L1 measure. What is the L1 measure? In L1 measure, suppose there are 2 data points. One is the 3, another is the 5. Okay, so if you make L1 measure, then what will happen? It will be like you'll take the distance between these two directly. That is, it will be like 3 minus 5, and we'll make the bar of it. Make the bar of it. Yes, we'll make the bar of it. Yes, so the result will be 2. That is the L1. What is the L2? This is known as the Manhattan distance. L1 is known as what? Manhattan distance. It is known as the, it's very difficult to write. Manhattan, okay. Anyhow, Manhattan distance it is. Now we have the L2. What is the L2 actually? In case of L2, what do you do? In case of L2, we use the squared. It is known as the squared distance, L2. Okay. It's the squared distance. How we do that? For the same data type, 3 and 5, what will do? It will be like 3 minus 5 whole square is equals to how much? 4. You can use that distance also. Now next we have L3. What is L3 basically? In case of L3, it is known as the Euclidean distance, the most famous actually. Euclid. You can write it down, okay, somewhere. It's very important. It is Euclidean distance. It is what? It is do like this: 3 minus 5 square, and it will be rooted. Square root of this value. Got it? So for 2 data objects, 3 and 5, we can get different value for the Manhattan, square, and Euclidean distance. Okay. Also here we have explained that what, here there is another thing is explained over here, a cosine similarity that works for the document clustering, and that's too complex. That's not as easy at last 3. So I'm not going through that because we're not going to use that also. Okay. Are you guys clear with that? Any doubt, guys, with this Manhattan, square, and Euclidean distance? No, L1, L2, L3?
L3 is square root again inside square, both will be same, right? It will even out to be L3 will be equal to L1 only, no?
No, L3 will not be equals to L1. In this case, it might be same, sir. But for sparse data, for long data, it will be completely different, sir.
Okay.
Like for this data is okay. Suppose okay. Let me, sir, give you another example. Okay. Suppose how to get it new? Yeah. Yeah, so suppose there is a data set, there is a 2D data. Here it is 1, 5 is a data point, another data is, it's a 2D data, okay? One is the 7 and it's a 3, okay? And there's another data might be in this 2D data, there is another data, suppose 2, 8. Okay, so what will happen? What will happen in case of L1? If you do it with L1, what will happen? It is very simple. That what we'll do in this case, we'll just use the minus. I think I'm using wrong tool. It is this minus this. That's it. That's it. That's it. So how much it becomes? It will be 1 minus 7 minus 2. 1 minus 7 minus 2. For the 1D, D-wise, it will be doing the thing. 1 minus 7 minus 2 is one data. And then 5 minus 3 minus 8. Okay, so how much it becomes? How much it becomes for L1? It becomes 1 minus 7 means 6 and 2 means 4. And it becomes what? I mean, mod operations will be there always. And 5 minus 3, 2 minus 6 is 6. It becomes 4, 6. 4, 6 is become as a 4, 6 will become the distance between these 3 points. Okay. For L2, how much it will be there then? It will be 16 by 36. Yes, but if you do it separately, then it will be some different values always. So 1 minus 7 square, like that. In this way, we can do different calculations over there. And we can get the different lesson in L1, L2, and L3. But the most important thing is the cosine similarity should be used whenever there is a document. If there is a no document, then there is no point of doing so. So cosine similarity, I'm not covering for that purpose. For document clustering only, we need the cosine similarity distance. Okay. Now the minimum, the third point is that the minimum distance. So what is the minimum distance? It is the measure of closeness between an object and centroid. So for each distance between the centroid and all other objects, the minimum distance will be selected first. And whenever we'll find the minimum distance, that object will be assigned to that particular centroid. Yes. So from each centroid, you are getting the distance between all other objects. Wherever there is a minimum distance, that you are putting to that particular group with that particular centroid. Next step is to get the mean calculation. I'll calculate the mean. The mean will be calculated based on the newly retrieved database values. The mean will be calculated on that particular way. So that is the third step. And then is the convergence criteria. That is the number of maximum iterations permissible is reached or not, no change of centroid values, or zero movement of object from one cluster to another. These are the things when it happens, we'll stop the K-means algorithm. Yes, now we'll go through with a particular example over here. So before we go through with this particular example, can you please solve a particular example, K-means problem? If you give the data, some data I'll give. Can you do it? I'll put into the chat box. Okay, I have given you a data. That's the data for you. One-dimensional data, simple data. And K is equals to 2. So this is the input for you. Can you see into the chat box?
Yes, sir.
Yeah. So can you just tell me what K values you want to check? So that all can do it. So K1 is equals to, suppose you have taken 3. Anything you can take, right? And the second centroid, K2, we have taken as 45. Now, can you calculate and tell me that what will be the result after first iteration of K-means? So 5 minutes for you. Is it okay? Hope that you are solving this, right? You can send me a direct message into the chat box as a result. So this is the problem. I put it here also. The data is 3153 6545 3223. And the two cases are there. Two groups we are going to divide the data based on their similarity. We have taken the initial centroid as 3 and 45. So if you use this notepad, can you see my notepad? Hello guys, can you see my notepad, participants?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. We are able to see that.
Okay, so two are there. One is 3, another is 45, two centroids. So as we told that we are using a for loop over there, that for each centroid we'll find the distance between all other objects, correct? So we'll see that which one is closer to it. So for take the first object, what is the first object? We'll take the first object, that is 3, correct? So we'll see 3. 3, what is the distance between 3 and 3? 3 minus 3. Let it be Manhattan, okay, plain Manhattan distance. It will be easier for us to calculate now. And 45. 45 minus 3 is equals to how much? 42. So which is having the least distance? Which is having the least distance? Which is having the least distance? This item 3. Yeah, 3, right? So 3 will be added to the centroid 3. So 3 is added with the value 3. Okay, now we'll see the next item. What is the next item? 1. 1 is closer to 3. 3 minus 1 is equals to how much? 2. Correct? And 45 minus 1 is equals to how much? 44. So which is the most similarity? 1 is having the most similarity with whom? 45 or 3?
No, not clear, sir. Actually, I don't know how you are picking that number. 3 is there. K is what? K equal to 2 means what, sir?
K is equal to 2 means 2 clusters we are going to create. 2 groups we are going to create at the end.
Okay, fine.
Yeah,
K
that's what.
3 and that 3, 1 all are input, no?
Yeah. 3, 1, 5, 3, 6, 65,
okay,
45,
fine,
32, 23
fine.
are the input data type. That is the N.
Okay.
Okay. Let me go to the algorithm here parallelly. Okay. So this is the algorithm. Okay. This is a formal algorithm. So we'll go through that. So what is the input? D is a data set containing N objects. K is the number of clusters. Okay, sir.
Yes, sir. Yes, sir.
Yeah. So what is the N over here now? This is the N. Here, this is the N, right? This is the N data set.
Okay.
Yes, and this is the K. We have to give the input. Now K is equals to how much? 2.
Okay.
Okay. So now go to the slide. Output will be a set of K clusters. So 2 clusters will be there at the end, sir.
Okay.
Okay. Now the step 1, the first step, randomly chose K objects from D as the initial cluster centroids.
Okay.
Okay. So that's what we are doing over here. That's what we are doing over here. We have taken, sorry. Oh, what is that? Yeah, we have selected these two. K1 is equals to 3 you have taken, and K2 is equals to 45 you have taken. So this is fulfilling this step 1. We have randomly chosen that. You can choose something else also. I have chosen 3 and 45. Others can choose anything else.
Okay, from the given data itself, you are choosing two things. Okay.
Yeah. Randomly chosen K objects from D. From D is written, sir. From this data set only you have to choose.
Done.
Yeah. So that is done now. 3 and 45. Other participants, please interact in case of any doubt. Okay. So that is done now. Now what's the next step? Second step is very important. For each of the objects in D. For each of the objects in D. So for each of the objects means we'll start from the first object. D is the data set, na? So for each of the objects in D, so for each of the objects means 3, 1, 5, 3, 65, 45, 32, 23. These are the each of the objects, right? Hello, sir.
Yes, sir.
Yeah. Anyone else? Soumya, madam, can you please put into the group if they have any doubt, let them ask and clear KMeans. You can ask me any doubt, participants, and clear the doubt. Otherwise, Matlab is of no use now. If I go and
Sir, if you don't mind, I'll suggest one thing. Can you put it in Excel and can you just drag it so that it will take less time to explain and understand?
No, sir. Step by step, I have to explain, sir.
Okay, fine.
Only 7, 8 data are there. Only 8 data are there. Not much, sir.
Okay, sir.
Okay, sir. So we are now picking for each data. So 3 you have taken. Okay, you have taken 3, then 1. Then we'll see that. I'll just put 3, 1, 5, 3, 6, 5. I'll just put all together. 5, 3, 5, 3. Then what do you have? 5, 3, 65, 45. 65, 45. 32, 23.
32, 23, yes.
Yes, these are the data we have. So we have to calculate distance between the cluster. Na? With the cluster, we'll see the distance. And the least distance will be added over there. So 1 is having the least distance with the cluster centroid 3. Not with the 45, because with the 45, the distance is too much, 44. Least distance is where? With the cluster centroid 3. So we'll add 1 also into that cluster. Which cluster we'll add? We'll put into the least distance cluster. That is 3, 3. With the 3, we'll add the 3 and 1. Is it okay?
Okay, sir.
Yes. So what you're doing basically for each of the objects in the data set, that is the input data set of n objects, compute distance between the current object and k cluster centroids. That's what we're doing first. Computing the distance between the current object. We are calculating the distance in this way. Current object and the cluster centroids. That's what we're doing, right? Yes, and assign the current object to the cluster to which it is closest. So assign the current object to the cluster to which it is closest. So we are adding to that particular cluster. That's it. Yes?
Yeah. 5 minus.
Fine, na? Aarti, are you getting Aarti? Many are having no response.
Sir, the first one is 3 minus 3. First one supposed to be.
Sir, that 3 minus 3 supposed to be 0. No?
But that's what it's not.
Yeah, it's better to have. You in some algorithms they skip that. Okay, that's also possible. It's not mandatory, but you can have that. It will, for a big data set, it will doesn't matter anything actually. For big data set with thousands of dimensions, and GBs of data, it doesn't matter. Even for MBs of data, it doesn't matter.
No, sir. The thing is 3 minus 3 is supposed to be 0, na?
Oh, sorry. Yeah.
That's what we are asking, right?
Okay, not that. Okay. So 5 minus 3 will do like that with the distance calculation. That will be 2.
2. So 44.
So here it will be 45 minus
3
minus 5. 3 minus 5.
Minus.
Sorry. 3 minus 5. It will be 2. We'll make it mod. Okay. We're making it mod. That's it. 45 minus 5 it should be 40.
Matlab.
Soumya madam, please mute that participant who's making a noise from there. Now we have 3 minus which one? 3 minus 3 only. 3 has
3
appeared
minus
twice,
3.
right?
Yeah.
Yeah. 45 minus 3, 42. So this 1, 3, and 5, 1, 3, and 5 go into the cluster centroid 3. Correct now? Because the least distance. 65 minus 3, how much? 62.
2.
45 minus 65. How much? Sorry,
20.
I should write 3 minus 65 is better. It will look with uniformity, correct? Na? 45 minus 65, how much it is?
20.
20. So which one is the least here? 65 is closer to 45 or 3?
Closer to 20, sir. Sorry.
Closer to
Closer to the
45.
centroid 45,
45.
na?
45.
Yeah, so
Closer to
we'll put
45.
we'll put over there on that group. Yeah, yeah. Now we'll be having 3 minus 45.
45.
3 minus 45 is 42.
2.
Sir,
And here we
equals.
have 45 minus 45 is equals to 0. So which one is the least?
Directly.
This is the least. 45 will put. Now 3 minus 32, how much it is? 29. Yes. And
Yes, sir.
here it is 45 minus 32. How much it is?
13.
1, 3, 13. Which one is the least? 13 is least or 29 is the least? 13 is the least,
13
right?
is the least.
So we'll put that to the 32. Then we have 23. So 3 minus 23 is how much? 20.
20.
And 45 minus 23 is how much?
22.
22. So when is it the least?
20 is the least. It
20
goes
is
to
the least.
3
23
category.
is to
3
be in
category.
category.
It should be into the category
3
of
category.
3.
3.
so 23.
K1.
Yeah, 23 will be in the category of 3. Okay, so after that, if you've gone through, then you have completed up to which level? Second step is completed for you. Step 2 is completed for you, correct?
Yes, sir.
Assign the current object to the cluster to which it is closest. Yes, now the third step, we'll go to the third step. What is the third step? Compute the cluster centers of each cluster. Compute the cluster centers of each cluster. This becomes the new cluster centroids. So we have to compute the cluster centers of each cluster. How to compute the cluster centers? Now these things are over, na? These things are over now. Now these cluster centers mean value you have to collect. How to collect that? You have to add these things. 3 plus 3 plus 1 plus 3 plus 5 plus 23. So how much it will be? Tell me how much? 28, 31, 32, and 6, 38. So 38 divided by how many objects are there? 6 objects, correct?
So out of
6.33, sir.
6.33.
Out of which
That's
one must be 0 actually. Okay, fine, no problem. This is for understanding.
okay, yeah. So it is 45 plus 65. So how much? 110 plus 45. How much it is? 155, 185, 187. So 187 divided by 4. How much it is?
46.75.
46.75 is happening. So now this becomes the next cluster centroid. This becomes the next cluster centroid now. Last time it was what? Randomly you have selected, right? 3 and 45 from the
3
data
and
set.
45.
Yeah, now it has become 6 and 46. So one iteration is completed. First iteration completed now. Understood now? Now the second iteration will start. See,
Sir?
the first iteration, yeah.
How many
Hello?
iterations we supposed to do it like this?
It depends upon when there is no change in the cluster centroid. I mean, there will be a time there will be no change in the cluster centroid. Up to this you can do, or you can do something like some convergent criteria. You can make some other, mechanism you can employ over there. So it's upon the data set to data set, clustering to clustering is different actually.
Repeatedly
Understood?
we have to get the similar number, no, sir? Close by numbers.
Yeah. So now you have to use what? 6.33 and 46.75 as an input for the same data set. What's the data set? This is the data set 3 1 5 3 6 5 4 5 3 2 2 3. You'll get the, after that you'll get new centroid again. After that you have to go through with the third iteration. Then you will get the new centroid again. In this way you will get the correct groups of these two objects. So from this particular object you can see that in one group 3 1 5 3 and 23 will be there. In another group 32 45 and 65 will be there. This is a very simple example. For complex data also KMeans will be working the same way and efficiently. Any doubt, guys? Anyone having any doubt?
No, sir.
Okay, fine. So okay, Soma ma'am has requested to complete early. So okay, so this is the same example we are using for 2D data. Okay, sorry, for 1D data, but the data set is very large. So I'll give you the PPT to you. The same thing is being done over here. Okay, for the KMeans. So you have understood the KMeans problem, right? So now you can go to this particular slide and we can open that Matlab works. Okay, so you know, right? It is the online portal for Matlab.
Yes, sir. We know.
Yeah, so now I'll go through with a Matlab problem over here only. So let me just open that problem, Matlab session. So we'll go through with the Matlab specific KMeans algorithm execution. So wait a minute, let it be opens. I've created one specific problem for you. So it will not take much time. Shomai ma'am wants me to complete the session by 3:45. So I hope that it will be happening. Madam?
Sure, sir, sure.
Yeah. So we'll having a Matlab for machine learning. We'll see that how it does now. Now we'll create the generate. We'll generate the data set first. How will generate the data set? There is a code for this. We'll use this. I'll explain the code. See this. Now X is a data set. It will be generating a data set. It's a 2D data set. See that one randomly you are generating 100 rows by 2 columns data set. For each randomly generated random values, we are multiplied by 0.75. Along with that, we are adding the one. Once is a method in Matlab method which will generate ones. So along with that, we are adding for each rows and each columns one value one. So 0.75 it is there. This 1.75 it will be. 0.23 will be this. 1.23 it will be like this. Yes. Along with that, so it is 100 rows by 2 columns. Then it is also appended with another 100 columns by 2 rows. Sorry, 100 rows by 2 columns, but it is using the minus operations so that we can get a different feeling, different data. The data should be unique, right? It should be having a non-uniformity, then the clustering will be better. Now the last example I have given is that there is a uniformity of the data. I mean the data you can easily read that how it will be clustering, because that was a very simple example. So this example is a bit of a difficult one. So we are giving this particular example for there here in this particular example. So we're creating this random example. I mean the randomly big data you're generating. Along with that, this stat set is used is for statistics, and the display you are making as final. So this particular will generate in a particular structure. That structure will be final. Okay, this stat set. See this now. The explanation is that random is normally distributed random number, and random three like rand n threefold returns 3 by 4 matrix. Okay, that's what it does basically. Are you clear, guys? Yes or no? Any doubt on this? Hello? Yes, this once method, like once mn, if it is once m comma n, it will return an m by n matrix of ones only. And stat set is nothing but it will create statistics option structure. That is the display is to amount. This display we are using that display comma final. So display is to amount of information displayed by the algorithm final. The display the final output actually. So it will display the final output. Display the final output. So if I press enter, it will be created. Hopefully, yes. See this here. We have created this. Two things is created. One is the X, another is the opts. If you open the X means you can see that. Let me open the X. It's taking time online. This is the Hello, I got disconnected actually. I got disconnected. Now I'll share again. Yeah, can you see, guys? Participants, can you hear me? Hello, can you hear me?
Yes, sir.
Yeah, so you can see that how the data is created. Yeah, you can see how the data is created now. See this, it is 200 by 2 double is created in this way. If you go down, it is loading still, so the data will be shown to you. Okay, so this data is created now. Now on that particular data, what we'll do, we'll execute the Matlab code for K-means algorithm. Yes, so how we'll execute this K-means algorithm? Check it out. I'll just copy and I'll explain it to you. Yeah, you can see that is IDX. This will be the distance will be shown over there. Okay, C is the number of cluster centroids as given the input over here. So X is the data input which you are giving. So this X is the data input which you are giving to K-means. 4 is the randomly selected 4 cluster centroids will be available. Randomly selected 4 cluster centers will be given over there. Understood? Randomly selected 4 cluster centroids will be selected from there, and that will be executed. That will be used for seeking the distance. Then distance measure is used as a city block. City block is the Manhattan distance. That is the plane distance, x minus y. That's it. No square, nothing. Manhattan distance only. The first L1 distance measure that is being used. So we are specifying that over here. Replicate 5 times. 5 times it will be operating. And options, I mean, from which particular structure you are doing it by using ops. This ops we created in the last time. Based on that, you are doing the clustering. So it's very easy in Matlab just to execute. That's it. Press enter. That's enough. How many iterations took for first? 7 iteration. Total sum of distance is this much. Second iteration, that much distance. Second replicate, third replicate, this much. The least distance is this. Yes, base total sum of distance is that. That is being created now. Yes, now we'll plot the data. Now we'll plot the data. How will plot the data? We'll see this now. This is the code for plotting the data. See, we are plotting X from the IDX structure. We are getting is equals to 1 means we are getting the 1 and 2 row. We are seeing that it's a red label. We are labeling the data points into the output screen as a red. Marker size is 12. Hold on means it will be holding on and keep on adding the other values. Otherwise, the single values will be shown only. So hold on is a must one here. Now from the second row you are getting, then marking as the blue and the marker size is all 12. Then in the third, in the fourth, we are getting this data in the red, blue, green, and yellow colors. And then you are plotting it. Yes, plotting the cluster centroid 1 and 2. Kx means it will give the scatteredly, it will display, the points. If you just give K, then it will be line. Okay, this is a different thing actually. This is not work. I think it should be this. It should be blue. It's wrongly provided here. I'll just change the colors. Yeah, it will not be, otherwise it will give error. Yeah, so after that we are displaying by using the scattered plot. I mean, just the points will be displayed, no connecting. Marker size is 15 aligned with this 3, so it will be like a cross. It will be like a cross. X like a cross. This cross will be there, okay, separately, and width will be 3, so it will be a big cross. I mean the bold cross. Yes, and the legend we are writing that cluster 1, cluster 2, cluster 3, cluster 4, centroids location. Title of the chart will be what? Cluster assignments and centroids. So let's start. Let's press enter. So this is the thing you got. Yeah. You can see that. So you got this data. Okay, this is the cluster centroid. Once in the middle, it is there. Means the calculation is very correct. Nah? So this is the red. This is the values. You can go to the anything. You can see the values. See this. X and Y. So these values are being displayed over there. These values are being displayed. This is the X, Y values. So all the values are being displayed over here. The clusters centroids are selected. These are, and after the iterations and K-means execution, these are the iterations we got. These are things we got actually today. These are the clusters centroids we got. Got it? This is a final clustering result. So you see that these are the data provided into 2D space. By using the K-means clustering, we have got into different levels, into different, this greens belongs to one group, this red points belong to one group, this yellow points belongs to one group, and this blue points belongs to another group. And these cross marks are the centroids. I hope that you understood. There will be no issues, I think. Yes. Yes. Now, if you want to see the cluster centroid data, I'll just show it to you. We'll see that what are the cluster centroids are. Okay. What are the cluster centroids are there? We just want to see. So we'll press enter and we'll use this code for that. See what we'll use one for loop, small for loop. That is from I equals to 1 to size C, 1 by 1 we'll go through with that. Size C. See, this is the number of centroids. What is the number of centroids? 4, right? It was 4, right? Yeah, you have selected 4, correct? See here. What you have used? You have used 4. See, after X, we have used 4. So we have used 4 over there. Correct. Now the display is centroid. We're displaying number 2 string I, and we are getting it and displaying it over here. Okay. So now I press enter means it's supposed to display here. See this. This display. Okay. So guys, I got disconnected again and again connected. I hope that you understood that concept, how to execute Matlab using K-means. Any doubt you have? Soumya madam, I have completed in 3:45.
Sure, sir. Sure, sir. I request participants, if they have any query, they can take 5 minutes.
So this code also, will it be given to the participants?
Yeah, this code also I'll give it to you, sir.
Thank you, sir.
Sir,
Thank you,
surely,
Thanks
sir,
for very nice
I'll request
explanation.
resource persons to share all that they can share with participants, and after the workshop, I'll share with all participants, sir, surely.
Done.
Yeah.
So is it clear, like any doubt in K-means algorithm? See this, you can get lots of code in Matlab in online, that there is no doubt on that.
Fine.
But the concept should be very clear. Otherwise, just will execute few lines of code. That's it.
True.
Okay.
So any doubt you have, anyone on K-means algorithm, why you are using that, how it's working and all these things?
Okay, if nothing, can we end session for today? Can I get permission from participants? Can we?
Yes, ma'am.
Yeah. Thank you, sir. Thank you, all participants. See you all tomorrow morning. Happy evening. Thank you all.
Ma'am, today's feedback link?
I shared, no, ma'am. In the chat, I already shared.
No, share it again, madam. They might have not got many of them.
Sorry, ma'am, I did not see that. Now I got it.
Yeah, it's there.
I'm sorry, Soumya, ma'am.
No problem, ma'am. No problem. Hope you all got it. Yeah.
Ma'am, not able to see that. Can you please share it once again?
Ma'am, can I ask anybody to copy that and share, because I'm using phone now?
Sure.
Yeah,
I can see
I'll
what
do
I
it,
shared
ma'am.
earlier. Yeah. I think as host, Tanvir sir, are you there?
Yeah. Someone has sent over there. It's there.
Yeah, because as host, I don't know whether participants are able to copy paste. Did you all receive it?
Ma'am, I have sent it to Tanvir sir. Tanvir sir again
Tanvir
can
sir,
resend it to
please
everyone.
copy paste once again in the chat, sir. I am in the
Already
phone.
I've seen and updated also. Submitted also.
Did you all receive?
Yes, I put into the Zoom session. You can give the feedback now, guys. Participants, you can give the feedback now. I have put into the group. I mean the chat.
Yeah, thank you, sir. Did you all receive it now? Okay. With that, shall we end the session?
Sir, madam, wait for 2-3 minutes. Let them just go through maybe up to the chat box.
Hi, ma'am. They are leaving, sir. I think it's done. Yeah. Okay, thank you all. Happy evening. Thank you, sir.
Thank you, madam. Thank you all. Thank you all participants.